Now we're looking at notes 11.4, multiply and divide rationals. So when multiplying, first you will factor the numerator and denominator just like we did on 11-4 simplify. Then, same as we did then, we will state the restrictions on the variables first before we cancel any matching factors. Remember, still tops with bottoms. And then last, similarly, we will clean up and simplify. So it is very, very similar. So looking at number 1, multiply. So you notice I have a monomial on top, monomial on top, monomial on bottom, monomial on bottom. So nothing can be factored. So that's kind of nice. We go straight to stating the restrictions. So remember, our rules are we cannot have 0 in the denominator of any fraction. So what would make this denominator equal to 0? Well, if x were equal to 0, that would make the denominator 0. Also, y being 0 would make the denominator 0. So in this case, both x and y cannot equal 0. Similar here, it's actually the exact same. X cannot equal 0, y cannot equal 0. We've already got it. No reason to write it twice. Okay, so then, once I've stated my restrictions, I can cancel matching factors. So in this case, I have a lot of things that can cancel because I've got an x squared on top that can cancel with this x squared on bottom. Okay, I've got a y to the 5th on top that can simplify with this y on bottom. So y to the 5th over y is going to give me y to the 4th. Okay, I have an x to the 8th here that can simplify with this x to the 3rd. That would produce x to the 5th on top. All right, I have a 15 over 3 that can simplify to 5 on top. I have a 2 over 8 that can simplify to 4 on the bottom. And, oh, I thought I was done with my y's, but you know what, I'm going to go ahead and rewrite just to show you that that's okay. So here on top I've got 5. Remember, the number should go in front. Everything here is in red. I've crossed it out. So I've got 5, x to the 5th, y to the 4th. Okay, and then on bottom, I've only got the 4y squared. So notice I still have y's. It kind of was getting messy over here, so it was hard to see. So if I need to clean up and simplify more. So here, the 5 and the 4 can't simplify. I've only got x on top, no x on bottom. So that would give me y squared on top. So my final answer would be 5x to the 5th, y squared over 4, with my restrictions of x cannot equal 0 and y cannot equal 0. All right, so look at number 2. On number 2, there is a lot of factoring that can be done. So in the numerator here, I can factor out a GCF of y. Then I'd have x minus 5 in parentheses. Okay, on bottom, that's a linear binomial. Doesn't have a GCF, doesn't have a lead negative, so it's going to stay. All right, times that trinomial has a GCF of x, so x squared minus x minus 20. And then this monomial, remember, you don't want to do anything with those, so leave it alone. This trinomial inside can likely be factored further, so we're going to go ahead and rewrite everything else. Okay, and then numbers that multiply to negative 20 but add to negative 1. That is possible. Oh, don't forget my GCF of x out in front. So that would be x minus 5, x plus 4, okay, over x squared y. So before I get excited and start canceling factors, I want to look at my denominators. So my restrictions would be x cannot equal negative 4, as well as 0, and then y cannot equal 0, because we're looking at both denominators here, and what would make the denominators equal to 0. Okay, so now I can cancel. I've got an x plus 4 with an x plus 4. I've got a y with a y, and x over x squared would simplify to just x on bottom. So then I've actually got 2 x minus 5s on top, so I'm going to go ahead and write that x minus 5 squared on top, and all I have on bottom is x. Okay, so that leaves me with my answer and my restrictions here. All right, so look at number 3. On number 3, first binomial here, I have a GCF of 5. Okay, on bottom, I have a GCF of x. And then on top here, that would factor to x plus 3, x minus 1. Okay, and then on bottom, that linear binomial does not factor further. Okay, before I get excited again, you want to make sure and give those restrictions. So x cannot equal 0, x cannot equal -3, and x cannot equal -5. So then my x plus 3's cancel, and nothing else cancels because that's a -5 and that's a +5. So that's all I can do with this one. I've got 5, x minus 5, x minus 1 on top. And then on bottom, I've got x times x plus 5. And just a word to the wise, you want to keep everything factored. Don't worry about foiling it back together or anything like that. Just keep it nice factored form. All right, so we're done with number 3. Okay, moving on to number 4. So on top here, I can factor the difference of squares. On bottom, I have a GCF of 2. All right, on top, nothing can be done with that linear binomial. On bottom here, no GCF, and the a value is not 1. So if you're not comfortable with doing the guess and check method that I typically use, then off to the side, you will want to do grouping. Okay, whether you use grouping or guess and check, it will factor the same. All right, I get 2x plus 3 and x minus 4 when I factor in my head. Okay, and so then since I'm all factored out, I need to go ahead and list my restrictions. X cannot equal, that doesn't make any difference because there's not an x included in that factor. So x cannot equal -3, x cannot equal +4. And then think about that one. If you said that one not equal to 0, you'd -3 and then you divide by 2, so it'd be -3/2. Okay, then I can start canceling. X plus 3 with x plus 3, x minus 4 with x minus 4. That leaves me with x plus 4 on top. I think that's it on top. Yep, and on bottom it leaves me with 2, that 2 there, and then 2x plus 3. And remember, don't multiply back, just leave it factored like it is. It's perfect. Okay, next, last multiply example. All right, this linear binomial on top can't be messed with. This linear binomial on bottom is not in standard form. Standard form would be -x plus 2, which would leave me with a lead negative. So I need to factor out the lead negative, which would make x minus 2 on the inside. Okay, and then this is a difference of squares, x plus 2, x minus 2. All right, and then this factors to x plus 2, x minus 1. Okay, so I'm all factored out, so then I need to go ahead and give my restrictions. So x cannot equal 2, x cannot equal -2, so I'm going to put plus or minus 2. It can't equal either, plus or minus. Remember, the negative out in front doesn't make any difference. It doesn't have an x attached out in front. And then the last thing that x cannot equal is +1 because of that. Okay, so then I can start canceling. And that's all that goes. So that leaves me with x plus 2 on top over negative out in front, x minus 1 on bottom. Now, I'm not a fan of negatives in the denominator, as you probably know. So pull that negative to the numerator, put it up top, so that way the denominator has no negative in it. Not out in front anyway. Alrighty, so box that up. You're good to go. So last thing we need to talk about here is division. So division of these rationals is pretty much very, very similar to division of just regular old numbers. So remember, 1/2 divided by 3/4, you're going to flip the second and multiply, or keep it, change it, flip it. So keep it, change it to multiplication, flip it. So here, that simplifies 2. So that would give me 1 times 2, which is 2. And that's 1 times 3, which is 3. So it's very, very similar. So here, we are going to keep it, change it to multiplication, and then flip it. And then we just act like it's a multiplication problem. Okay, so that monomial doesn't get messed with. This has a GCF of x squared, okay, which leaves me with 2x minus 3. All right, and then this has a GCF of x, which leaves me with 4x squared minus 9. And then don't mess with the monomial. So then this is still a difference of squares, so it can go further, so I need to. 14x to the third, x squared. Remember, no canceling allowed yet. Need to factor completely first. So that difference of squares is 2x plus 3, 2x minus 3, over that monomial of 21x. So I've factored completely. Now I need to talk to you about restrictions. So restrictions for division is a tad different, and I'm sorry. So you do worry about the numerators here. The denominators here. So x cannot equal 0 because of that and because of that. X cannot also equal positive 3/2 because move the 3 over, it's positive, divide by 2. But you also have to go back to the original problem. In the original problem, that was in the denominator. In other words, that was in the denominator. So for the original problem, that was in the denominator, that cannot equal 0. So that means for division problems only, you look at both denominators, you also look at the numerator of the second because it was the denominator in the beginning. So we've already got the 0 covered. We've already got the positive 3/2 covered, but we need to also say that negative 3/2 is a no-no because that would produce 0 in the denominator of the original problem. So then I can go ahead and start canceling. So 2x minus 3 with 2x minus 3, and then x with x, and then x third with x squared would make x on top. And then both of these are divisible by 7, this twice and this 3 times. So on top, all I have is x, 2x plus 3. And then on bottom, all I have is 3, it looks like. Yep. On top I had a 2. That's why I left that little space there. So I had a 2 on top, an x on top, and then the 2x plus 3. And then on bottom I had 3, and that was it. Okay, so that leaves me with all the examples I'm going to do with you today. I really would like for you to try this one on your own so I can see if you've got those restrictions down, especially with the division. So come to class ready to share your answer for this problem.